Good, good. How are you?
Oh man, I'm doing good. I'm doing good. Keeping busy, trying to progress as always, right? Trying to always
Yeah,
move forward.
yeah,
Glad to join everybody tonight. Seems like a really awesome talk we got ahead of us.
yeah. That's gonna be fun. How about yourself, Dustin? I think you might have been talking, but I don't know.
Yeah, that was me.
Okay.
Yeah, I'm doing good. It's like I don't know, late for me, but it's like it's nice to have a couple hours between work and doing anything. Like a night owl anyway. So it's kind of nice.
Hmm.
Yeah.
So I was reading your background, like because Marco helps me set up these meetups, and it's really impressive. You know, we were kind of thinking about, the next topic. And I think like what we were looking at was like, I get a lot of feedback from this group asking for projects, like things that are real world, things that they can use. So like the whole tiles with the map is really cool. And it seems like you won a hackathon too, right?
I
So
did. Yeah.
yeah, can you tell us
Yeah.
a little bit about that? That seems really interesting.
Yeah, that's part of the talk.
Okay.
But
Yeah,
uh, yeah, I just found it on Dev.Post.
yeah,
And yeah, like I don't know. I think like mid last year, I like someone told me about Dev.Post. And I was like, all right, cool. I'm gonna check this website for stuff. And then I did one over like, I don't know, 2 weekends or something. And I won like, I don't know, something silly, like a monitor. And I was like, all right, I'm addicted to this now. I'm just gonna check this website every other weekend and see if there's anything that's like cool and fun that I want to do for probably
yeah.
the next few weeks.
For the record, I think let me just pull it up here. I think I might have
Man, that sounds pretty awesome. What's that website?
so Dev
It's called Dev.Post. Oh yeah, go ahead.
Yeah, I'm about to bring it up here. Hang on, I'll share my screen real quick. And just let me know if you can see. Got like a million
Sweet. If that's not motivation, I don't know what is.
right? Like,
That's
yeah,
pretty awesome.
this group and letting you guys like know about cool stuff you can do. Yeah, like so I saw like their hackathons that are going on at Dev.Post, and seems like the site's kind of slow right now, but yeah, it seems really interesting. And Marco was kind of like talking about this too. Marco is like the assistant like coordinator for the programs that we put together here at the group, and he's just kind of like saying, um, like he's interested in like looking for hackathons. So here we go. Like the group is also interested in looking for hackathons. We have like a group called Team Hack, which kind of started this whole thing where we also practice getting better at code and building things together. I'll bring up that website as well. So Team Hack is like a little project that we started here at JavaScript like HackBuddy. People can sign up and learn how to code. We have a whole GitHub repo that you can go to, and let's see here. This is the Team Hack repo. So we're just like practicing projects. Some of these projects are like in React or vanilla JavaScript. So it's a chance to kind of learn like how to like code, especially like if you're planning on working like at a bigger company. We try to do it well there. But then this is kind of like the evolution of that, like going in and trying some of these projects, right? Like trying some of these hackathons and seeing like, what's out there, because you might win some money, right? And that's kind of cool. So yeah, did you want to say something, Dustin?
Oh no, yeah, no, winning is cool. I like winning is great. I love winning.
Yeah, sounds like something in a movie. So I'll just quickly like get the main stuff out of the way for newcomers, right? Like if you're new here, this is our group, JavaScript LA/HackBuddy. And so if you ever like want to know about what meetups we have, just go to this website, javascriptla.net, and then you can like click into these meetups. We also have the Team Hack website that I mentioned earlier. And then basically, we also have a Discord that you can go to and chat with people online and talk to myself, talk to everybody, about like coding in general and get better at it. And then if you want to be able to watch a lot of the videos that we put out for these meetups, we have a YouTube channel. And like, let's go ahead and actually, I'm like,
Hey, what's
clicking
going
so
on,
fast.
YouTube? I am VJ.
That's me. Clicking so fast here. But all of our videos are basically, on the youtube.com/hackbuddyorg site. And so you can go in here and watch all the previous meetups if you like. And this meetup tonight will also be there. Also have some other videos like how-tos, like explaining like different methods in JavaScript and React. Definitely check it out. It's a good resource. And subscribe, let us know how we can do better, because we're always listening to your feedback and want to help you out, like, especially to become a better programmer for your job and all that. So with all that, if anybody has any questions, feel free to reach out to me during this chat tonight. And then also be on the Discord channel if you need to, and you can message me there as well. But I'll go ahead and turn this over to Dustin.
All right, cool. Let me share my screen. All right, cool. This is gonna, everyone can see my screen. It's good.
Yeah.
All right, cool. This is, we'll see how long this takes. It's gonna be like kind of meandering. We'll see what we get to. Hopefully everyone learns a lot. So let's just kind of do, I don't know, background about me. Right now, I'm a data engineer, infrastructure engineer, backend engineer, whatever, at a company called Numina. We're a super small company, about 6 people. We deploy these little things, cameras that kind of look like, I don't know, big soda cans, out into the world. They've got these cameras in here. Those cameras then essentially do all of the work of like a traffic study. They count people, they count bikes, they count cars, whatever. And I do pretty much everything except for like the stuff that runs on the device. All the stuff that goes in the cloud, that's me. The APIs, the infrastructure. Yeah, really cool little company. Really glad to be working there right now. Before Numina, and I guess kind of now still, I write some classes for Codecademy, mostly about databases, like mostly Postgres, a little bit of Python. I might be doing some stuff with like Go. We'll see. But yeah, also really enjoy like sort of teaching, which is, how you end up at Codecademy. And before that, I was working as a GIS engineer, mostly like on map stuff, which is how I got interested in what we're going to talk about tonight, at a company called Geophy. You can talk about the tools a little bit, but if anyone's interested in knowing more about Airflow or PostGIS or DBT, those were some of sort of the tools that I used. So yeah, I'm here because I won a hackathon, and I want to talk about sort of what that hackathon was, sort of how I thought about sort of, I don't know, being like setting myself up for success in that event. It was actually a pretty long one, so August to October, which gives you a lot of time to play with. So the hackathon was all about let's call it promoting, showing that you can do a lot with sort of this new processor that Amazon, well, not Amazon, ARM released. So ARM is the chip manufacturer that's responsible for a lot of processors. And then they worked with Amazon and they released a specific type of EC2 instance that uses their processors, these Graviton 2 processors. And sort of the marketing pitch that Amazon makes is that these are really efficient machines. They've got a really sort of good instruction set, and they're energy efficient. And because of that, we can offer you, sort of better compute than maybe an Intel chip or what you would get if you were buying an Intel instance, for a little bit less money. So all in all, price performance ends up being like, I don't know, maybe 40, 50% better than what you could currently get maybe like a year and a half ago. And then within the last like 6 months, they've released the Graviton 3, which, they allege is even better. I think they announced that at reInvent in December. So yeah, it's all about showing that this type of instance can be really performant. Then, here's some marketing stuff, but, oh, my screen just cut out. Hold on, I'm still good. Sorry, that was definitely just me kicking a wire. Anyway, here's some marketing stuff, but for the most part, like real companies actually use Graviton. It's not exclusively marketing nonsense. Like Twitter is actually using it. Snapchat is actually using it. Superbase is actually using it. Like they're good instances. Like I use them at my job. Like it's not fake. But I had to convince myself of that. So, like let's go ahead and try out this hackathon. So yeah, saw this. If you were here earlier, you have seen that I sort of found this event on Dev.Post and was like, all right, let's put something on a Graviton instance and let's see if these marketing claims are real. That's just kind of how I operate. Like I wanted to see if it was real. So let's do a demo first, or like kind of an introduction, and then we'll get into some of the weeds. Let's see if I can play this video. I'm not going to make you watch me talk over me talking. So I'll try and just cut the audio and narrate over some of the interesting stuff. For the most part, this is what you've got. You've got a map of the world. Right now we're in New York, and it's got a bunch of features. As you zoom in, you get sort of more interesting features, smaller features. And as you zoom out, as you saw here, you see maybe larger features. This area sort of in the middle looked like it had small houses, so those weren't there at the sort of zoomed out level. And then in addition to having polygons, we've got road layers and point layers, where these points are like, businesses. The polygons are like individual houses or maybe apartment buildings or whatever. And then what I thought would be really cool would be if you could explore this data. So I made this kind of hacky sort of like query language where a user could just open up a tab. You can tell that I'm not a front-end dev if that wasn't clear yet. Sort of just open up this little tab, type in a little syntax that I had documentation for, and they can filter the objects that they receive based on a few things that are associated with each object that I load into the map. So in this case, it's filtering by a postcode, and then we see that that's the only area of the map that returns. And then for the most part, I think everything else is kind of covered in the bulk of the talk. I just wanted to be able to show you the, something like that, something sort of live, because I have sort of taken down the website in the month since. So what I thought it would be cool to be able to do is like, this could let us know about like transit accessibility. You could do something like, where are all the wheelchair accessible stations in the New York City Metro? You could like cluster by a concentration of businesses. So right now we're in San Francisco, and then you could, apply a filter like, I don't know, like all of the restaurants, and you might see sort of like a similar distribution. I don't know what this is filtering for, but this type of sort of like high level geospatial exploration was what I was really going for. You can look into things about like pedestrian safety. So because the data set that I used has this really rich set of tags that are crowdsourced, you get things that maybe like a Google Maps wouldn't necessarily have. So Google Maps might have like, okay, yeah, there's a road there, there's a bus stop there, but it wouldn't have like, are you allowed to park on the right side, or are you allowed to like, like what are the like alternate side parking hours, or like is there a bike lane, things like that. It also can tell you stuff that maybe not everyone would be concerned about, but you might be concerned about, like, like, where is there a sidewalk? Well, that's actually a lot of people would be concerned about that, but like, maybe something like, oh, is there a bench at this bus stop? Because, you might have to wait 30 minutes or whatever. So I wanted to build something that, exposed all this cool geospatial information. And yeah, you can sort of, I mean, this is just like pure, like, not like being too much of a developer. I could have made a nicer UI for this for sure. But yeah, you could learn how to do some querying. So I kind of want to talk about how I came to this idea. So when I was working at Geophy, I was working as a data engineer, and what Geophy did was pretty similar to like what Zillow does. We didn't buy and sell houses. We never tried that. But what we did do is like predict house prices, and then we would sort of, interact with like, let's say like real estate investment trusts, and we would say, yeah, this is what we think your portfolio is worth. These are some maybe interesting targets for acquisition based on what you've sort of already got in the area. This might make sense for you. And our data scientists, what they would do is they would have these models that were oftentimes based on like pretty fine-grained geospatial data, stuff like how many hospitals are in a 10-minute walk or 10-minute drive of a given property. And this might, make its price go up 0.25%. But, in aggregate, all this information was really useful. What we found was that we spent a lot of time sort of going back and forth about what was a useful feature. So we might want to represent something like, how many grocery stores are in a 10-minute walk, but then you have to argue with, like everyone in your organization about what is actually a grocery store. We would have maybe like 10 versions, 10 different interpretations of what a grocery store was. And it was really only sort of data engineers or people who like really knew SQL. And even then, like, we're only really comfortable with sort of geospatial stuff that could go in and like poke around sort of at will. So yeah, then we would talk about like, oh, well, they only serve sandwiches. Do they count as a grocery store? And it's a waste of time. I wanted to do something that would, like, in theory, make that process have gone faster if I could have, gone back in time. So I started to think about like what project components I might need. I would for sure need a geospatial data set. I obviously couldn't use like the data that I used at my real job at the time. That would get me in a lot of trouble. So I probably was going to use something open source like OpenStreetMap. I would need a database to store it. Maybe I would need some pipelines. Maybe I would need an API. Like almost certainly I would need an API for, something like this. I would need to sort of manage all of the infrastructure. And then depending on sort of the scale that I was operating at, I might want to see, like some caching, might want to be able to do some tracing to make sure that sort of the API is performing well, maybe some like metrics or sidecars to make sure, again, that it's performing well. Then, obviously the front end, and there might be some other stuff that sort of emerges. But when I was first starting off, I was just kind of looking at like what's absolutely like 100% most important. And in red, that's like you need the data, you need an API, you need a place to deploy, and you need a front end. And then the stuff in blue and gray, maybe that's not so important. The stuff in blue, from my perspective, like day after I found out about this, was like, yeah, I'm probably going to need that. Stuff in gray is kind of like, that would be really nice to have. That's how I would do this if I was going to, I don't know, maybe like turn this into something real. So I'm going to do a quick intro to web mapping because I think that'll make this a little bit easier for everyone. And hopefully it's interesting to everyone as well. So when you go on Google, they serve effectively two styles of layers. They'll serve like a vector layer, which is everything on top of like a base map. So you'll get a picture of the actual, like a satellite picture of the actual ground, the buildings, like what you see on the left. And you'll get, maybe like an overlay, of all the buildings, something like what you see on the right. I was most interested in serving vector layers because for the most part, serving like a base map is most often, and I don't mean to like overgeneralize here, it's mostly just serving like image files, just at the right time. And that can be cool. That can absolutely be like a challenging thing. Like I'm sure there's a team of very, very like scary smart people who are responsible just for serving the image tiles for like Google Maps. But for me, sort of like the more interesting challenge was like, can I serve vector tiles? And we can get into sort of why that's a little bit more complicated and why that can be sort of a more fun challenge for me. Then there's another distinction that I kind of want to bring up. So they're dynamic tile servers and then they're static tile servers. So a static tile server is going to serve like a file, just like you're serving static content to a website, like, I don't know, an HTML file, a .png file, whatever. For the most part, your base maps are almost always going to be static because, you know, the satellite imagery probably doesn't change so often. You don't need to dynamically generate new satellite imagery. You also probably couldn't. I'm not saying that there might not be a situation where I guess you could, but you know, for the most part, you probably aren't going to. Dynamic tile servers might be closer to sort of like rendering an object on top of a base map. So if you have an API, you load in the object and then you just load it in at the appropriate location. That's kind of what a dynamic tile server is. So if you've got like, I don't know, app that tracks like all of the cars in a fleet or something, that's almost certainly going to be using like a dynamic tile server because that's going to change pretty frequently. In exchange for sort of getting that flexibility, you kind of have to pay for it because, you know, you have to have it in, you have to have the ability to render on the fly rather than just serving a file. So you pay for the disk and sort of whatever processing. And you could also serve off of a database, which is what I ended up doing, but that's kind of a spoiler. So the way that sort of these tiles works, and if, again, you go to Google, it kind of explains itself a bit. If you zoom in, you'll see like little squares loading in almost at the same time, but not quite. So all tile servers work on what's called like a hierarchical index, where the world is represented by like one tile, and then it's split into 4 subtiles. And then each of those tiles is split into 4 subtiles and so forth until you end up with very zoomed in, really detailed tiles where, you know, the world is like, you know, hundreds of thousands of tiles across and hundreds of thousands of tiles high that each contain, you know, very detailed information, whereas at level sort of 1 over here, you see very minimal information. This is also kind of another advantage of a dynamic tile server, because with a static tile server, you end up having to store a lot of files. Because if you want to store, like, I don't know, let's say all of the United States, you're storing all of the United States at level 1. Okay, great, that's 1 file. You're storing all of the United States at level 2. Looks like that might be like, I don't know, 2 files. But then you've also got, I mean, literally hundreds of millions of files by the time that you're down at level 20. So maybe you don't go down to level 20, maybe you stop at level 12 or something, but you know, it kind of depends on the precision and the level of detail that you want to serve. So that's it on tile servers for a little bit. Go back to the project. So my first idea was, back when I was a data engineer at this real estate company, I was thinking like, oh, wouldn't it just be great if like my product managers could like write a query and it would render the map in full for them. So Mapbox has this really cool tool called Tippecanoe. And if you give it a JSON file with a geospatial object, it will turn it into tiles for you, static tiles. Actually, yeah, static tiles, because it's a static like JSON file, and it turns into, you know, like a bunch of smaller static tiles. But I've run Tippecanoe on large data sets before, and it's like it makes your computer sound like it's about to like go into space. It's like, it's really CPU intensive. And you know, I'm not running like the best hardware. So, you know, I thought maybe it would be cool to have like a remote server where you can submit jobs to Tippecanoe. And I really like that idea. And frankly, I kind of want to do it again. I want to try it again, but involved writing a little bit of C, which was more than I wanted to write. And, you know, it's like kind of niche. And I just realized that like, man, this doesn't even solve the problem that I was like really hoping to solve. So I tried for about 3 days and kind of quit on that. I have that picture of this television show on Netflix. It's called The $1 Billion Code. It's about the development of Google Earth. There's a great scene that talks about tile generation in there, which is, I mean, of course I loved it, but you know, kind of recommend everyone check it out if this is what you're interested in. It's like 4 hours. Maybe it could have been a movie, but just, you know, I enjoyed it. So my second attempt was sort of what I demoed a couple minutes ago. What I wanted to do was have a global dynamic tile server reading OpenStreetMap data. So I can use Postgres as my database. It's kind of a sort of standard choice. And I can add in this extension called PostGIS. PostGIS allows you to generate vector tiles from objects stored in a database. So knowing that, all I needed to do was make sure that one, I could store sort of enough data for it to be interesting, that I could make this database performant, that I could handle sort of hundreds of requests per user per minute, because you can imagine that if you've got maybe, I don't know, a couple square miles, as you zoom out, you're not making one request every time that you scroll your mouse wheel up a level. You're making, let's say 30, because your screen might be full of 30 tiles or whatever. So a regular user just kind of panning around can generate like hundreds of requests. And then, you know, I put this in, you know, with a huge grain of salt. The rest is infrastructure, meaning that like that's kind of what I was comfortable with and enjoyed, and I didn't think would be too difficult. Sometimes I'm wrong. The infrastructure ended up kind of being pretty challenging as well. But this is sort of my my main idea. All right. I actually want to do a quick demo. I set up a small geospatial database right before this. And I just want to make sure that you can now all see like a SQL window. Is that correct? Was that a yes?
Yes, yes.
Oh yeah, all right, cool, sorry. So what PostGIS does is it allows you to add geospatial data into any regular Postgres database. So I set up a database like, you know, an hour ago, and I just loaded in a small data set. So just run this first query. This is a problem. It may have gotten, hopefully I did not disconnect from it. So, you know, this is the price that you pay for trying to do things live. All right, cool. I think that should be finished. Let's make sure. All right, cool. Did I do that right? Oh, yeah, there we go. Cool. So what you get is, in addition to sort of, you know, this regular table, you get this field called geometry that stores the latitude and longitude that defines an object. And in some sort of clients, you can go into like a viewer and you can see, all right, cool, we've got some neighborhoods. And you can click, oh, that's East Elmhurst, that's like Midtown, and you see the shapes. And you can do a lot of sort of like regular SQL stuff operating on the shapes that makes it easy to create applications that use geospatial objects, just like you would use like a number or, you know, user ID or whatever. You can order by area using like ST area. You can simplify the shapes and save a little bit of storage space. So in this case, I've used a function called st-simplify, and you can kind of see that some places they're a little bit jagged, but we cut off a lot of the polygons, and that leads to sort of a lot better storage performance because the shape still is like 90% correct, but it's also like, 90% smaller, which, if you ask me, is a pretty good trade-off. You can do maybe more complicated stuff, like you can show the centroids of any given shape, and you can do stuff like, show the most eastern or most western elements of your set by doing stuff like, select X, the left, right coordinates. Yeah, so that's like a pretty basic primer into how all of this works. Essentially, I used queries that were, closer to this than kind of the demo that I showed, but to operate on data that I had loaded in from OpenStreetMap, and using sort of this this cool new function that I learned about like right before the hackathon, st as mvt geom, which just means as a tile, pretty much. You can intersect shapes, or you can intersect like a square, a tile, on top of a group of neighborhoods, or a group of objects, and then you can ship it up as a binary, or Postgres will handle all of the logic that creates a binary, not like an executable, like a just binary object. Sorry, I should have been more clear there. And then it just sends it back to your client. And if you've got the right front end, it'll understand that as a tile. And it's all sort of a lot of development from like Mapbox and Foursquare and all of these sort of companies that have sort of a vested, and Google, of course, that have like a vested interest in like geospatial applications a little bit, have made this sort of these practices a little bit more standard. So I've mentioned OpenStreetMap a little bit. It's essentially Wikipedia for maps. It's crowdsourced mapping. Anyone can go in and contribute a business, or like a street lamp. You can put literally whatever you want in there. I mean, not literally, but pretty much everything you want. There's stuff that's super detailed, like benches on bus stops. This makes it a really interesting source because it shows you what maybe people are interested in the area. So unfortunately, you can kind of see gaps in OpenStreetMap where there just aren't contributions. And that's kind of unfortunate, because in my mind, it's like a lot better than relying on, even like official sources sometimes. Because official sources will never catch if an elevator is broken on their website as fast as like, someone like a person contributing information to like an open source database. So like in this example, we've got a bus station, and Google tells us it's the MR, it's Livingston and Smith Street, and might be handicapped accessible, but we get a lot more information from we get B67, we get shelter, yes, all of this stuff from OpenStreetMap as well. So I've got my database, and I think I've got my geospatial DB, but let's just make sure. To validate sort of the queries that I was doing, I ran some benchmarks on a Graviton hosted PostGIS instance. So I used something called pgbench, which is a tool for benchmarking database performance. I said that I always kind of like to do a couple day sprint, applying like a work term to my personal projects, but it is what it is. I always kind of like to do like a couple day sprint to validate an idea. So what I ended up doing was launching a few different databases on a few different EC2 instances, and then running pgbench. And I was pretty pleased with the results. It looked like, sorry, I should mention M6GD is just a reference to the Graviton instances. T3 is an Intel instance. And then the type of disk is GP2, GP3, or NVMe8. This doesn't so much matter, but what does matter is that sort of the best that we could do on Graviton, which is 885 a second, was a good percent better than what we could get on an Intel chip. But this isn't really a sort of a realistic benchmark. So I then ran a query that was more like the queries that I was showing you in that short demo on a set of polygons and points, and saw that, yeah, okay, the performance has dropped a ton. We went down from like 700, 800 transactions a second to maybe 70 transactions a second. But when you compare the Graviton instance with the Intel instance, we still see like a really nice performance improvement. So after I had done these tests, I was like, all right, cool, I'm all in. This actually works. This is a real, this is a real thing. I'm gonna build this. So we've got our geospatial DB, we've got our data. I think the next thing to focus on was like the actual service that was gonna return us our points. So at this point, I was like getting kind of busy, but I was super happy with sort of the progress that I had made. I figured that I could figure out how to do a worst case version of this in a couple days, given that I was happy with the baseline performance that I got. So I started to think, what would the absolute worst case look like? And it would be, just serve a state or two with no custom querying layer and deploy it on 2 instances, one for static content and the API, and then another for the database. And I kind of worked towards that first, but my calendar freed up and I got pretty lucky actually. And I was able to, integrate a ton more. So the service is going to be, not dissimilar from this query over here, except just wrapped in Go. I like to write most of my services in Go, but really any sort of any language would have done. Like it could be JavaScript, it could be Python. Like as long as it's got like a SQL client, it would do. All the API needs to do is send SQL to a database. It's like really no different than sending user ID equals 125 or whatever. Cool. So this is like the system design bit where I tried to like build a system that I consider almost production ready. I definitely made some mistakes. I'm happy to share this if anyone is interested. But I'm going to go through this sort of in small parts. So there are a lot of moving pieces here. This is, one of the advantages of hackathons. Like I like trying new tools when I can. I didn't write a lot of Terraform. Terraform is an infrastructure as code tool from HashiCorp. It allows you to write code that provisions your infrastructure. So if you're managing like 15 servers, or, thousands of servers, or even 5 servers, like having code, having a file that says, this is exactly how I set up this instance, like this is like exactly how I'm serving this content, it can be really helpful. And for me, being able to like run Terraform destroy on a Sunday night, and then on a Friday afternoon, when I was ready to work on it again, run Terraform up, or I'm sorry, Terraform apply, without like, having to like sit there and like fiddle with like an AWS console or a GCP console, trying to remember what I did like 5 days ago. It's like just a huge time saver. Also nice to like help me enforce not cheating, and like, no, it's not cheating, but not like getting distracted and working on it in the week. I try and sort of time box myself to weekends on these things. So one thing that I haven't talked about was that OpenStreetMap is really big. So one of the big components is that OpenStreetMap is about 50 gig ultra compressed, but it works out to maybe 1.5 terabytes uncompressed. The reason is that they've got this really really efficient like protocol buffer that makes it so that they can serve it as a tiny file. But then when you put it in Postgres, because you've got to worry about indexing and all of this extra stuff, you end up with a much larger file than what you download from their website. And unfortunately, the way that you load Postgres or OSM into like a Postgres or a Postgres instance, PostGIS instance, is with some of these open source tools that work great, but you need to have more memory than the size of the file that you're importing. So that meant that I needed a 64 gig memory instance, which I didn't want to buy and maintain, because I knew that I wouldn't need that much memory just to run my database. For the most part, my database could probably like do great off of like 8 gigs of memory, if that, so I bought a Spot instance, which is just Amazon's sort of cheaper instance options. Technically, they say that they'll give you a 5-minute warning if they're going to take it from you. But the idea with Spot instances is that you pay 30% of the cost of a regular instance, and it can be interrupted from you with like a couple minutes warning. It's definitely worth it to save 70%, if you ask me, especially if you're running something like it's maybe like a job that's only going to take like a night or less than a day. I think the instance interrupt rate is something like 20% less. So like, depends how, like what your risk appetite is. But for me, it made perfect sense. So I bought in this Spot instance. I did the download job and I put it into the database that I was talking about. I was actually kind of really excited to see these statistics as well, like same sort of style of benchmark as above, where the Intel chip just did not load as fast when I had it as my builder instance as sort of what I saw on the ARM chip, on the Graviton instance, which was like kind of a nice like sort of extra, like I don't know, a couple points that I felt like I could get myself by including that fact. So I have service and API in red because I want to roll back to the actual way that the front end works, because I think that that's an interesting piece as well. So like, trust me, I'll get back to that, but I did want to talk about orchestration as well. So covered the database, but I also had, my core API and a bunch of these other sort of like small services that kind of were just nice polish that, again, if I was going to make this real, I definitely would have included, or, definitely would include, wanted to include, because I was aspiring for this to be something a little bit real. So I put everything on ECS. So ECS is Amazon's Elastic Container Service. If you're familiar with Docker containers, ECS is just a way to run Docker containers. What you do is you specify, I've got this many computers, this many servers, and I would like all of them to be available for ECS. And you submit a job to ECS, you submit essentially a Docker file to ECS, and it says, okay, how much memory do you need? How many CPUs do you need for this job? And it says, I'll find a computer that you've already purchased that I can place this task onto. That can be really useful because you can have sort of whatever computers are available always working, or you can have, maybe 20 applications and a fleet of a few instances, and it will say, I will like do the hard sort of like planning for you and allocate these tasks optimally so you can turn off some of these instances more often. So yeah, everything was orchestrated with ECS. And I ended up running a few extra containers. But yeah, this is probably the fun, interesting part. How to make the actual tile API work properly. So like, this is what I didn't want. I didn't want like this sort of clunky experience where, like half of the map loads and you've got this weird square. Like I really just wanted to make sure that like whatever I built, like nobody was going to be miserable using it. Even if they wanted to like, I don't know, hop over to like London and like zoom into the middle of like the city and like, do whatever, New York or LA, like any big city, like it should be usable. And that means loading in a lot of objects. So there were performance considerations that I had to take into account, like how large is too large for a tile? Like polygons operate way differently than points. You need to like add tricks in. That trick about simplification was something I learned sort of through this hackathon. Do I have a desired response time? Like how long of seeing a little gray square or something like this does it take for someone to get annoyed? Will the API be the bottleneck? Will the database be the bottleneck? Like if someone reasonably wants to use this, will I be serving them like a ton of content? In which case, like nobody's going to use this from their phone if they're getting 50 megs just to like, check the, like if a bus has a bench. Like, I mean, I don't know, maybe you have unlimited data. Maybe that's like kind of a silly constraint, but I think that everyone prefers a web page that doesn't send them just 50 megs of junk, if at all possible. So the API was written in Go, as I mentioned, and then I used Redis sort of to try and be a cache. This doesn't really help with some of the questions about like serving content, but it does help with response time. So the API can only do so much. Essentially, the API just takes those X, Y, and Z coordinates that I was talking about when I was talking about tiles, and it converts them to a Latin long, and then it sends that request to the database. But what I needed was a front end that would intelligently be sending my API X, Y, and Z coordinates, right? So my API can't do anything unless you get it what is the user looking at? And that's where OpenLayers comes in. OpenLayers is a JavaScript, I guess, library. Yeah, I don't know. They're very large. They've got sort of like a lot of functionality. It's frankly a little bit bloated, but like it does a really good job, period. Like it was really easy to use, and I don't write that much JavaScript. So OpenLayers sends the X, Y, and Z coordinates, and then I just need to worry about sort of these maybe edge cases. Like how do you deal with like a really long road getting loaded in if someone is only looking at part of it? How do you deal with like making sure that if someone moves their screen really fast, they don't get like double loads? How do we make sure that when they're zoomed out, they're getting the most relevant features? You can do something like sort by area and give them the most, like the largest, or, like random, the top 500 or something like that. And then we want to do sort of things like, give me all the pizzerias in the area. That just comes down to being a where query after the tile generation step. I used Redis to cache, like I mentioned. This ended up, I think, being a little bit of bloat because I ended up not using it too much. Probably just because I didn't have enough users or I was too cautious with retention. These tiles are like, they're binary, Postgres returns a binary, or again, like binary data, and averaged out to about 32 to 40K for a tile in a city. So you can imagine that could be a lot if you've got a lot of users and they're all in different areas, and they're all sort of zooming in and zooming out. But for the most part, like these tiles just weren't so large that they would blow up my Redis instance. Redis normally was operating at like 2%. Now, having Redis did make things a lot faster. This was the usage, I think over like a day or so. At one point, averaged like 50 requests a minute, which really isn't too much over the course of a day. But what we see is that every request to the tile API averaged about 47 milliseconds, but then requests to the database averaged like 50. So there's not like a big circle for Redis here, but you can kind of infer that Redis was lower than Redis was lower than 50 by a decent amount. In practice, I know that Redis was like under 10 milliseconds for a response for a tile, but to what extent does this matter? It's like we're all talking about unperceptible time. So premature optimization, but like kind of a fun problem to solve. So I was happy with this. The cache is good. The API is good. The pipelines to orchestrate everything are good. I kind of just sort of needed to like tie everything together. What I did was I put an application load balancer in front of everything. And I was like, all right, cool. The front end is just going to call, this load balancer that I'm going to make, tiles at maphub.com. Wasn't the most creative name, just maphub.dev. That was the name of the domain that I bought for this. it's just going to call this, and then I'm going to have a few instances of the API sitting behind it. The load balancer is going to load balance between a few of them, and we're going to put Nginx essentially just in the middle to do compression. So the load balancer can't actually zip tiles for you or can't zip data for you, but Nginx can. So if I just write an Nginx container, put it into my ECS cluster, and tell it to sit in front of my API, everything will come back zipped. And that makes everything that comes out to the user like 50% smaller, about. At least in this case, depends on what you're serving. But in this case, it ended up being like 30 to 50%. Maybe not the best that you can do with Nginx, but you know, like I was pretty happy with it. Again, maybe premature optimization, but you know, worth learning. Kind of enjoy doing stuff like this. So then I want to talk about tracing. This was just to make an argument about like things like this are traces. They just show wherever request went. Did it hit the database? Did it hit someplace else? I added in Amazon's default tracer or tracing service called X-Ray as an extra container because again, I had the ECS cluster up, may as well use it. You know, it got me a few nice charts. It helped me debug some performance with the cache and sort of understand which tiles were slow and why. That helped me tune maybe some special ways to handle like big polygons or whatever. But, you know, for the most part, it was just one of those things that you add because like I kind of wanted the challenge and it was fun. Metric sidecars, that was too much for me. I just didn't, sorry, not today. I didn't need sort of really fine-grained metrics. This wasn't like a production service, no need. And then if anyone's familiar with like hosting a static website on AWS, you can just dump all of your static files into a bucket on S3, and then you can put CloudFront in front of it. And you know, if you've got a domain name, you can associate your domain name with CloudFront, and you don't need a server. CloudFront just serves those files off of S3. So that made my life a little bit easier because, you know, even though I talked about all the stuff that I put in this this ECS cluster that I didn't need, you know, like at least I could keep that out of here without an extra server. So, you know, no metrics containers. This was pretty much about everything that I was going to do. That was it. You know, that's the project. That was the design. Do kind of want to talk about like how I felt about this afterwards. I think that the addition of Nginx was really good. I was really happy with that. I was really happy with sort of adopting ECS. I had never really worked with ECS before like a month prior to the hackathon. So, you know, loved that. And I was really happy with sort of the database benchmarking that I did. I had never sort of taken a scientific approach to something like that. So, you know, thrilled there. And then, you know, like I was still like, you know, living my life outside of this during this time. It was like a 6-week hackathon, and those are really easy to get like just kind of bogged down in. So like, I'm really glad that like I was able to time box this to weekends. I was glad that I was able to plan it out. I was glad that like those first couple like, you know, fake sprints went so well. What didn't go so well is, you know, sort of design choices. This is just, you know, like infrastructure stuff that I wasn't pleased with. I think I really thought that the API would be worse than the database. And I made some choices that I didn't really love. The API wasn't the bottleneck. Redis was probably over provisioned. And, you know, there's some real in the weeds bug with how the load balancer worked. You know, I'm obviously happy to talk to anyone if they have questions about that. But, you know, like none of this I can really complain about. I was super happy with how it turned out. And yeah, that's about it. I think that's the last one. So any questions?
Nice job. Nice job. Do you hear me all right, by the way? I just want to confirm that because
Yep.
we were having audio issues. Okay. Yeah, this is really, really good. Very, very detailed too about like how exactly you went about, you know, doing your research, and then, you know, trying, like you said, like scientific method, right? You tried and you benchmarked, and then you started building towards your ideas and scratching out ideas. I love actually the fact that you talked a lot about like sprints, which is kind of like an agile term, you know, for those who are not as well versed in that, but just basically working in terms of like time frames that you say that you're going to work in 3 days or 2 weeks or something like that. But yeah, again, this is really good, very detailed, and I loved like how you explain little things like the you know, the use of the Postgres, and as well as the geospatial, you know, data sets and the API around that. And then, you know, how you like set up all of the infrastructure that you needed for AWS. So yeah, it was really, really overall very good. I was going to ask you, what kind of feedback did you get from the hackathon itself?
Yeah, that's actually kind of interesting. So I think the judging period for this one was really, so, okay. Part of the reason that I went through all of this like extra reliability stuff was because earlier in the year, in 2021, I did a hackathon, and like I finished maybe like 2 or 3 weeks earlier than I needed to. Like I just was busy late and, you know, kind of free beforehand. So I was like, all right, cool, gonna finish early. And then like I kept getting messages, you know, from alerts that I had set up on Amazon that were like, hey, your thing is down. And I was like, oh geez, I need to fix this like right now. Like, I don't know, like if a judge visits and it's like broken, then it's like, well, I just wasted my time. So the only actual feedback that I got was like, despite my best efforts to make it as reliable as possible, I never actually tested it on Safari. And like one of the judges opened up a like an issue on the repo that I shared that said, hey, this thing is broken. And I was like, who is this guy? Why is he like, I don't like, there are literally 5 people that I care about feedback from right now. Like, he was one of the 5.
Yeah.
Yeah, so that was about the only feedback that I got. But I like, you know, I think he was in like London. So when I woke up, it was like the first thing that I saw in the morning, and I was like, oh, well, this is the first thing I'm doing today, I guess now. So
It's always something like that. Apple Safari, hey, you got to have that support too, you know.
yeah,
Safari is like the worst browser right now.
yeah, well,
Okay, so that's good. I want to open it up to questions too from everybody, because I know people have been like putting stuff in the chat too. So
oh, sorry, I didn't see a single one of those.
that's okay. Joey says, were you billed for running any instances through AWS through your testing?
I'm sorry, I heard you, but I think I missed a word.
Okay.
Could you repeat that?
Yeah, I just basically said, were you billed for running these instances through AWS while testing?
Oh, yeah, gotcha. Yeah, so I think there was a credit of like $50, $100. I don't quite remember. Dev.Post is pretty good about giving out credits. And yeah, so yeah, you do get billed. I think that overall, the thing that cost the most was the storage. So I'm not sure if I mentioned this, but I ended up not serving all of the world because the number one, like most expensive thing was storage, hot storage for the database. Like it needed to be really performant, really fast. And I think GP3 instances or something like, I want to say a terabyte is like $100 a month for like the good fast storage that you can run a real database on top of. So to, you know, like, yeah, I wasn't gonna, yeah, no, sorry. I couldn't blow all of my budget on that. But yeah, for the most part, like you can subsidize it pretty well with the credits. I went a little bit overboard on this one. I think all in all, I probably spent like $200 to keep it up for a few, I guess like 2 months overall, then minus the credits. So, less than $100 in. I was pretty happy with that.
Good stuff. We also have some comments. I guess Aaron said that you really like Go. And is that because, I guess I'll add to it, is that because you like that better than C? I think you mentioned that.
Yeah. So I do like Go. I think it's a very sort of easy language to pick up. At least for me, it was like a really easy language to pick up. It's like fun to write. I don't know. Yeah, I like Go. And yeah, I cannot. I mean, everyone keeps their monitor on like like a little bit of a stand. My like stand is like my my Learn C book, which I have like clearly not used ever. So yeah.
Actually, before we go down to the next question, I do want to ask you about that as well. Because I saw that you started off like with economics, I think, as your major.
Mhm.
And clearly, like from tonight, I can definitely tell that you know a lot about like computer science. And so I just wanted to ask you about like, your journey towards learning computer science and engineering to be able to come this far.
Yeah, sure. So I went to school for econ, and then at some point, probably like my junior year, my junior year, I like kind of realized that like econ doesn't like, it's not like it's not hard. I'm not going to sit here and say that it's not hard. But I realized that like the classes that I was taking for my econ major would like set me up to like work at a bank, which is cool, like, but I don't think that I was kind of cut out for that. I liked sort of like tinkering with like problems more. So I like did a big push on like taking as many like stats and data science and math courses as I could in those last 3 semesters. And then ended up working for a company that does sort of like quantitative analysis of stock prices, or like for litigation. And that was like a good learning experience, but still not quite like development. It was a lot of like data analysis. And sort of how it works at that place, it was the consulting company was that like, they tell you you've got, I mean, they don't tell you this. They say you've got 3 years, and look, we're not going to give you a raise after 3 years. You can stay here for as long as you want, but unless you've got like a master's or a PhD, like the raise isn't happening. So people leave after 3 years, and then they go do something else. And when it was my time, I was like, all right, I want to go be a developer. And I had already been doing a lot of data analysis, so like just was lucky enough to find a job doing sort of data engineering. I like did one project in school that was about GIS, which is how I like kind of was able to weasel, I mean, not weasel, like I didn't cheat anyone, but like weasel into like a job working sort of in GIS data engineering at this real estate company. Yeah. And then sort of once you've got like 8 hours a day just to learn how to do this stuff, it's just like, all right, cool. Now I don't have to do it at night.
Perfect. Yeah. So you set yourself up in a way where you could learn on the job and get paid for it, essentially.
Yeah, that helps a lot.
Yeah. That's actually beautiful. Like I do the same thing actually with my work too, right? Like it's a chance for me to learn on the job, get better at what I already know, and then like use the 8 hours a day to like get better as that, so well, 100% support. I don't think that's weaseling. I think that's actually like brilliant. So
Yeah. Oh, it's the best I could do.
yeah. So then do you want to dive into like how specifically you learned like Go or like, C and all this stuff? Did it just kind of come naturally, or did you just kind of like crack a whole bunch of textbooks? What
Um,
textbooks are you reading? What courses were you doing? Because you said you eventually got to Codecademy and you're writing the courses there.
yeah. So I started with like in school, I started writing a lot of R and MATLAB because like that's what you do because it's like sort of academic. And I think that was like a good starting point. That was just like, your professor, I got lucky because I did have some kind of background and that helps definitely. But your professor says like, this is the formula for pricing an option or like pricing a stock given these conditions, like write a program that prices these 1,000 stocks. It's like, all right, just do that then. But like I remember taking a machine learning course in like, I guess it was like 2014 or 15. And my professor never told me about like how GPUs work and stuff. So I was just sitting there trying to like train a model like on my laptop. And I was like, this isn't going well. I don't think this is right. But anyway, yeah, once I was like at work, and doing a little bit of data analysis, you start with like, or I started with like pandas, and I've got like, Python for data analysis. I'm just reading books off my bookshelf right now. It was like probably one of the early ones. All of the animal books, the O'Reilly books are like actually pretty good.
Yeah.
And then like, sort of as I got more interested in sort of like specific things, I started to look at like I guess more specific like use cases and I don't know. I don't actually know. I think like I tried some courses on like Udemy or Codecademy and DataQuest, but I'm not quite sure. I think it just ended up being a lot of tinkering, and then you kind of it just comes. I guess it just like shows up one day. Yeah, I don't know.
Yeah, very
I don't
cool.
think I haven't really bought like a book for programming for a while. I learned a lot about sort of like systems from designing data intensive applications. It's the O'Reilly book with the I don't know, like boar or wildebeest on it or something. That's a good one if you
Yeah.
want to learn about like
Very famous. Yeah.
like I actually, that the reason that I bought that, I think, was because like I was interviewing for a job when I was trying to leave consulting, and just like if they gave me like a programming question that was, like count the types of like, count how many steps you can take if like one of those like weird brain teaser questions, like I was like okay with those. But like if they gave me like a system design question, I was just like, oh, it's not going to be this place. And that kind of made me want to get more interested in like the big picture stuff because I don't know. I figure that like super long term, I'm probably gonna be doing more of that in my life than hands on keyboard. So may as well get used to thinking in that way, sort of now.
Absolutely. Yeah. This is good. This is great stuff. Does anybody else want to ask questions surrounding any of this conversation? You can also put in the
I got a
chat.
question.
Yeah.
Yeah, so like I really dug like your like system design work that you showed in like the AWS like pipeline that you like constructed. Like, so in my own dabblings with that stuff, it gets pretty jiggy. Like, did you basically like have any like resources that you referenced for like inspiration on how to like basically set that up, and like what services you wanted to actually implement during the like actual construction of this application you launched on AWS? Or was it kind of like just like spur of the moment, like try this, try that, and like, whatever kind of works? Is it kind of like something sporadic like that?
Yeah. I think that like I started watching like a lot of talks about how not even like the big companies do it, because I think that that's like if you just like, you can go back and like watch a talk called like, I mean, it doesn't matter. Like I'm making this up, but like if you type in like any company, I don't know, like Slack system design
Right.
2012, there's going to be like a great talk probably, you know, about like how that system was designed back then. There are a few really great channels on YouTube where if you just type in like system design interview, like they'll all show up. And then for like writing the actual infrastructure as code and like the real nitty gritty of like, oh, like how does like a subnet work within like a VPC, and like how do you like secure it so only these IP addresses can access your you know, like a certain resource. There's one that I really enjoyed. This guy's name is Anton Tra. I think that might be his name. I just put it in the chat. Yeah, does like really great videos on YouTube about like infrastructure and like in the weeds. Like he'll just have like a 30-minute video that's like, all right, this is how you set up like API gateway. And those are really useful as well.
So you do a lot like of DevOps work at your primary job. Would you call it like DevOps? Is that kind of like what you do? Because I know you mentioned you do a lot of backend stuff, but like almost like all the services that you're using, those are like a lot of the things that you would utilize doing DevOps.
Yeah, I think so. I've never sort of like seen myself as like a DevOps engineer. I think it's just more like that it's not done if it's not deployed. And it's just like, I would rather be able to deploy it myself. Like that's it. But yeah, you know, like infrastructure as code, like I like building, like build pipelines. So I don't have to worry about like, you know, I like making sort of like the stuff that's like, you know, kind of a pain a little bit easier. So yeah, I guess. But
Really cool, man. I appreciate it. Thank you.
yeah, absolutely.
Anyone else want to add to this conversation? We've got some other people on the call today that I think might be new, so feel free to speak up. And if you don't have any, oh, I see Aaron. Go ahead, Aaron.
Sorry, I had to step out and I missed the entire orchestration portion of your presentation. Did you use any software for the orchestration, or did you do that using like your own script? Well, I guess they all have scripts, but yeah.
Yeah, so like I didn't use like an Airflow or a Luigi, if that's like what you're asking.
I guess I was asking,
oh,
you know, like Kubernetes, like
oh yeah, sorry. I used ECS, Elastic Container Service, which is just you give it a Docker file, and then you give it memory and sort of like CPU constraints, and it places it on one of your instances for you. So it's not really fair to say that it's like Kubernetes Lite, but it does a lot of the stuff that Kubernetes does, and it abstracts it away from you. Yeah, so I mean, I could have done it on EKS or like, you know, a Kubernetes-like environment. But like, you know, I'm already prone to overkill. Like, I think that would have been a little bit too much for this. But yeah, I mean, it pretty easily could have just been on Kubernetes.
Thank you.
Any other questions? So yeah, you know, feel free, like I said, to put more questions in the chat if you want. But I think, yeah, like everything we've seen so far has been really great. And you know, I think you clearly definitely have shown us that, you know, like you have like this back-end talent, and it's just like super good. You're thinking about a lot of different things. I guess like holistically, like what did you want to solve like for maybe like the lay person, like the user who eventually consumes this, right? I know it's like maybe using the queries to like find, you know, like shelters and things like that. If you did have like a UX, right, like a front end, what would you imagine that to be like?
Yeah. Essentially, you type in, well, I'm not sure, right? Because maybe it could be something as simple as like you search for a tag, you search for like a thing. Well, it's difficult because with OpenStreetMap, they have like these tags. It's not like, I don't know. I've never actually thought about like how you go about searching on like a free form sort of like set of tags. But maybe it could just be as simple as like you've got all of the objects and you've got a search bar. And all you need to do is type in, you know, whatever, you know, tag you're looking for. Or maybe we could abstract that away by having like, you know, something smart that, you know, knows that like deli and sandwiches are like closely related and, you know, returns not exact matches or something. But essentially it could just be a search bar and the objects. And that's it. And then, you know, rather than having to maybe rely on like, I mean, it could do everything that, no, not everything, but it could do everything that like a Google map search does, but with sort of more contextual information because it's all sort of crowdsourced. That would be like the ideal situation, I think.
Yeah,
Um,
yeah.
and right now, I think that if you go on OpenStreetMap, they don't let you search because, you know, they're running on like kind of not like a shoestring budget, but like they are literally a charity. So they're not trying to pay extra for like egress and, you know, add extra services. They really do just want you to kind of like contribute or download and host your own for whatever you want to do. So yeah, you know, like something like that would be awesome.
Awesome. Okay. At this time, I guess we have one comment from Nikki who says she really appreciates the detail about the design and talking about the learnings from building the project. We have somebody just joining us. I do wanted to end it here, I guess, like, you know, I want to say thank you again for your time, you know, and I think this was really, really helpful. I would like to say, you know, you're more than welcome to come back, you know, anytime and present more stuff with our group and talk to us more, anything you're working on.
Cool.
Yeah. Do you have anything for us, like at the end, like that you wanted to say? Or
Oh, well, thanks for having me. Yeah, like really appreciate it, everyone. So thank you.
yeah, well done. Thank you again for the meeting with us, and hope to be in touch.
Cool. Sounds good. Have
All
a
right.
good one.
And everybody else, thank you for coming. We'll see you all at the next meetup. Bye, everyone. Good night.